This video is all about solution dilution, which is kind of fun to say. But dilution is just adding extra solvent to lower the concentration, to decrease the concentration of a solution. So when we say add a bunch of water to something we have made when we're cooking, we're diluting it, right? And so the amount of solute, the stuff in there stays the same, but we add more solvent. So in my example, adding more water. Oftentimes folks use a formula for dilution. They'll have the starting solution concentration times the starting volume, and then set that equal to the final solution concentration times the final volume. Sometimes that's written as, oh, let me get my pen. It's written differently in, in different avenues of science even. Sometimes C1V1 equals C2V2. Maybe you have seen it that way in, say, biology, for example. Us chemists most often like to write M1V1 equals M2V2, where, M is our molarity concentration. So if M is in our concentration in terms of molarity, it's what's my starting, my 1 molarity and my starting 1 volume and my ending molarity and ending volume. Concentrations and volumes can be most units as long as they are consistent. So as long as on both sides of the equation you have the molarity in the same units and the concentration in the same units. Here's an example. What if M1, molarity 1 is 12 molar? We don't know volume 1. We don't know how much we should use of that initial solution, but we know we want the final molarity to be 1.5 molar, and we know how much of it we want. We want 5 liters in the end. This happens a lot. How much of the initial solution should we use to get what we want in the end? This is actually a, pretty real life example. So we would set up M1V1 equals M2V2. So we'd say, okay, M1 is 12 molar. We don't know V1. That's multiply. So we'll take and we'll multiply M2, 1.5 molar or moles per liter times our V2, which is 5 liters. Okay, so to get V1 all alone in this algebra, we're going to divide both sides by 12 molar. Okay, so 12 molar, the molarity is going to cancel out with our molarity on top, or moles per liter. It's going to leave a unit of volume, which is great. So in our calculator, we do 1.5 times 5, divide by 12, and then for V1, I don't know about you, hopefully you're calculating this, I got 0.625 liters. So I would need 0.625 liters, and then I would dilute it up to 5 liters. I would add enough water so that the volume increased to 5 liters. So I'm going to dilute 0.625. Oh, sorry. I was going to say that right here. I'm going to dilute 0.625 liters. Sorry, I ran out of room for my liters. Of that 12 molar solution, and I'm going to dilute that up to as much water as it takes to get that up to 5 liters. Okay, let's try some more examples. In this example, what is the concentration of a solution made by diluting 15 milliliters of 5% sugar to 135 milliliters? Okay, so here is a nice math trick, a math word problem trick. When you are seeing a problem laid out like this, the of in this type of statement really means multiply. The of really means to multiply. So if it is saying, if we're asking you, what is the concentration of a solution made by diluting 15 milliliters of 5% sugar to 135 milliliters, we mean to find that concentration. You're going to take 15 milliliters. you are going to multiply by 5%. Okay. And then it says you want to get it to 35 milliliters. So you're going to divide by 135 milliliters because you want to know a final percent concentration. So you have diluted it to 135 milliliters for your final concentration. So we'll cancel out milliliters, and then you should get 0.56% for your concentration. So the of in that phrase, to basically get how much sugar you have, you'd multiply 15 milliliters times 5%, and then divide that answer by the total to find your new concentration. Let's try another example. What volume is necessary to prepare 400 milliliters of a 4.0% solution from a 12% solution? So again, that up, you're going to multiply. So you're going to go, okay, I have 400 milliliters, or I want to prepare 400 milliliters of a 4% solution. So I'm multiplying, and it's from a 12% solution. So that's going to cancel in percentage terms, and I will have a volume unit. And so I will get 133 milliliters. Now this only has like 2 sig figs and 2 sig figs. So how do we get this down to just 2 sig figs? That can be a little tricky. One way is to say, well, that's 1.3 times 10 to the second milliliters. You may forget that method or how to use scientific notation like that. Another way would be to just take your milliliters and get rid of milliliters and convert to liters. In every 1 big liter, there are 1,000 little milliliters. And then it might be easier to see how to round to exactly 2 sig figs and stop. We don't need that next 3. So just 0.13 liters, and then you'll have your correct sig figs. So think of, go ahead and multiply, and then of what? Of the 12% solution. And so you're going to divide by that. So it's just kind of a quick, straightforward way to accomplish these types of problems. Okay, we have one more example here. How would you prepare 250 milliliters of a 3.0 molar solution from a 7.5 molar solution? So this looks like M1V1 equals M2V2. Okay, so we've got a 3 molar solution, 250 milliliters of it is needed, and you've got a starting molarity of 7.5 molar, but not sure what volume of that solution to use. Divide both sides by 7.5 molar, and that will just cancel, and we'll have solved for V2, and our molarities cancel as units. And so then when you solve all this for V2, 3 times 250 divided by 7.5, you should get 100 milliliters for a unit. It only has 1 sig fig, and we should have 2 sig figs. So you could either convert that to scientific notation, like 1 times 10 to the liters, or, milliliters. That would still be in milliliters, right? We've just taken this and converted it to scientific notation. So that would be in milliliters. Or we could do converting it into liters. And if we convert it into liters, we'd have 0.10. And there would be our 2 sig figs. Here's our 2 sig figs in liters. Just getting a little ahead of myself. I was thinking, oh, next we'll switch it to liters, and I wrote liters instead of milliliters. Okay, so if we know that what we need is 0.10 liters of solution, what we will do is we will, we'll take and measure 0.10 liters of our 7.5 molar, what's essentially called a stock solution, the concentrated stuff. And then we'll dilute that stock solution. And we'll dilute it to 250 milliliters. So we're taking, 100 milliliters essentially, but we want 2 sig figs, so 0.10. And we'll then have to dilute it up to 250 milliliters to lower that concentration, because concentration goes down with dilutions. So hopefully now you feel confident about dilution calculation.